time dependent, right? So when you work with questions like these, I think what we're going to do is round to the nearest whole degree, because it gets really finicky if you don't use all the decimals, like every single decimal place. You don't come up with the answer that you're supposed to come up with. So yesterday we figured out one of these stretches. Like when you see a right triangle, guys, cut it out and work with it. Okay, if you see it, cut it like we did here. Boom, we labeled. Always look around the diagram. Is there something outside that I can bring in, right? We use Pythagorean theorem to find x, and then we multiplied it by 6, right? Times 6 to get the whole length of that bridge. Perfect, no problem there. When it comes to classifying here, we're gonna have to be a bit more careful, okay? So we knew that if they wanted us to find the interior angles of ABC, so you're looking at ABC as highlighted here, and so we basically cut this out. We know that these are 11.3 because we're told that all these stretches are 11.3, right? So we label it like that. And this stretch here is 2 times x, like 2 times x that we found here, because x is halfway through and another x is all the way to the other side, right? So we multiplied that length we found up here times 2 to label this side. And interior angles, by the way, there are 3, right? A triangle has 3 interior angles. If we find A, we can easily find B and C because they are the same. So we're going to find A first. So here we go. We go cosine of A because we have an SSS scenario, right? That's why I do trig before I do these questions. So you go minus 15.96 squared. Like you take that, square it, and then it's 11.3 squared plus 11.3 squared. And then at the bottom is just 2 times 11.3 times 11.3 because they're the same, and that is okay. And let's come up with the decimal there. So 11.3 squared plus 11.3 squared minus 15.96 squared. You get that at the top, 0.6584. And at the bottom, you get 255.38. Nope, I made a mistake. I went 35 instead of 38, so let's redo it. That's a really small number. And you will see what happens here. If I go shift cosine of that answer, you get really close to 90 degrees, right? Really, really close. So what I will do is I'll write down 89.85, which is roughly 90 degrees. You don't do this in the trig unit where you're just solving for angles, but this unit we will do this to classify most likely. And then it's in our best interest to just find the whole rounded to whole degrees. Okay, so we got 90 there. And I'm going to steal a little bit of space from this section here, okay? So A is done. B and C are the same, guys. Angle B is the exact same thing as angle C. And the way you're going to find it, just try to think through this, the way I'm doing that. It's 180 minus the one you know divided by 2, right? Because you take away the one angle you do know, and you split that difference in half and give it to these 2 angles here. So this is 90. 90 divided by 2 is 45. So Angle B and C, they're both this is actually okay to state it like that because these are all the same. Okay. All right, so now let's label these guys. ABC, I have to look myself. Okay, ABC is the orange one there. This one here, this is ABC. Okay. So triangle ABC, we're going to call that A right because of the 90, right? Because of this 90, it's a right isosceles because these two sides are the same, right? Isosceles. 90, and this is because of this, right? And then they want triangle ABD. By the way, triangle like that, triangle ABD is a right. What is that one? This one is also controversial. This one is a bit of a trouble case here. Watch this. I'm going to go up a bit. ABD. Let's draw it here. I'm going to copy that down. This is A, this is B, and this is D here. We know this is a 90. We know that this is 11.3. We know that this is 8. And what did we calculate this to be? It was 7.98 continued. Isn't that very close to 8? Right? Don't you think these should be the same? Right? So this is 7.9, which is approximately 8 feet. So I will never do this to you where it's so close that you're like, well, is it or isn't it, right? So just round it to, I will probably make a little note, round your answer up here to the nearest whole for this particular example. So now we know that this is the same as that. So it's a right isosceles as well. Not always going to be the case, but in this particular instance, they're very close. They're 8, both of them are 8. So it depends on the scenario, right? So you figure out the side lengths and then you figure that. So what I'm going to say here, I'm going to make a little note above this question. You good? Yeah. Let's put a little note here. A note up here. For B and C, we round to whole values for classification purposes. Values to classify, let's just put that one. To classify. So there we're not so concerned because we know that we're not getting an 8 here. We get 7.98, right? But if we used all of the decimals, right, it would probably be very close. Even the 90 degree we got would be close to 90 or exactly 90. So and a carpenter, I can guarantee you, would cut it to 8 feet. If he does the math and he gets 7.9, he or she, right, does the math, he gets 7.98, you probably cut it to 8 feet. And then if it needs to be shaved off a little bit, that you do it afterwards, right? Okay, we're gonna skip these ones for now, like the screen door, like so all of page 186 later. I'm just gonna put down later so you're not thinking you're missing notes or anything. Just put later on page 186. Panda, you should recognize this. This should ring a bell from your AC. So page 187. I think I'm gonna leave that for now. Looking at my time, I want to start quadrilaterals, giving you some, it's going to be note taking there for a bit. So, let's see. Yeah, we're going to also wait with this. So I'm going to stop the recording here so that